Hello and welcome. This is going to be our homework help video for the Graphing Quadratics quiz review. Let's get started with problem number 1 here. Sketch the graph of each function. Be sure to identify the vertex and at least 4 other points clearly. I know I say 4 other points, but the reality of these problems is that if it crosses through an exact point in the graph, we should bold that point to show that we understand that it's going right through that point. All right, problem number 1 looks like a good one to start with. What I'm going to do, in order to help me graph this, I'm going to convert it to vertex form. Let's go through that process. What I like to do to start is get my a value to be equal to 1 by dividing by the a value as we see it, and that kind of stores that on the other side of the equation underneath y. So it's going to be y divided by -1 equals x squared. But every term gets divided by that -1, so this is plus 6x plus 11. Now on the right side of this equation, I'm going to create the structure of vertex form, x blank squared, and start to fill in values. This plus 11 has got to stick around. The h value is going to always be half of this b value, keeps the same sign though. And off to the side, I could do some scratch work where I expand x plus 3 squared, x plus 3 times x plus 3. It's going to give me back my x squared. It's going to give me a plus 3x plus another 3x for a total of 6x. And it's also going to give me a plus 9 plus 6x. So we can see we got our x squared back. We got our 6x back, but we got a 9 and not an 11. So we're just going to subtract away what we call the extra. This is the extra here. Just going to subtract it away. Nope, not right there. Subtract it away right there. Let's keep going. I've still got y over -1 equals, I'm going to combine these terms at the end just to make this x plus 3 squared plus 2. Now we'll send the -1 back by multiplying everything by -1. So this becomes y equals negative x plus 3 squared minus 2. So now this is vertex form, and I can clearly see where the vertex is. The vertex is at -3, -2. Always remember to flip the sign of the number we see here when we get the x value of the vertex, but we keep the sign for the y value, just the way that it is, just something you got to memorize. All right, so -3, -2 is this point right here. Now, the parent function, x squared, normally goes up by 1, 4, 9. We have a value of a negative, so negative x squared is going to be -1, -4, -9. So this tells us as I move out from the vertex, horizontally, if I move 1 unit out, I should go 1 unit down. Back to the vertex, if I move 2 units out, I should move 4 units down. And at this point, we're off the graph. I'll go ahead and make it symmetrical by moving 1 unit left, 1 unit down, 2 units left, 4 units down. And connect these up with kind of a curved line to make your parabola. And maybe we should label that this is right here is the vertex. All right, so that was a lot of things in that one problem, converting standard form to vertex form and then graphing from vertex form. Let's try number 3. It could be a little bit more challenging because our a value is now a fraction, but we're not going to let that throw us off too much. First thing, let's position the vertex at h comma k. H here is -4, k is -2. So -4 comma -2 is going to be right about there. Now, let's write down my pattern for x squared, 1, 4, 9, 16. Maybe we'll need that. I'm going to manipulate that by the a value that I see right here. A is equal to 1/2. So 1/2 x squared is, just got to cut all these numbers in half. 0.5, 2, 4.5, 8, So as I move 1 unit out, I should go just a half unit up. If I move 2 units out, I should go 2 units up. If I move 3 units out, 1, 2, 3, I should go 4.5 units up. 1, 2, 3, 4.5, and I'm off the graph. So let me just make this symmetrical and connect up my lines, my dots with a curved line. Something like that. Real quick, I want to jump back to number 1. There's something I thought of. We should be double checking that our parabolas look relatively correct by looking at our c value. This tells us the y-intercept. The y-intercept of this equation should be -11. Let's just look at the parabola. Does that look like that line would cross my y-axis at -11 if it kept going down? Yeah, that looks about right, so that's a good way to double check. We can't do that if we're given the equation in vertex form. We could expand it into standard form and then double check, but I don't think that that'd be a good idea. Not really worth it. If we wanted to double check that this parabola is correct, we could just pick a point on it, -1, 2.5, plug it in, make sure that it balances. Or graph it in our calculator, make sure that they look about the same. All right. Equation of a parabola with a vertex of -2, 1. I'm just going to go right as soon as I see that, label it h and k. Has a maximum of 1 and also passes through the point -1, 0. If this is a point that it's going through, I'm going to label that just an x and a y. The fact that it has a maximum of 1, I can't really use that too much, but I'll use that maybe to kind of double check that my work is correct. All right, let's use vertex form here. Y equals a times x minus h squared plus k. Got to have this form memorized. Let's borrow our x and our y value, and let's plug in h and k. H and k will stay. These values for x and y will have to go back at the end. So 0 equals a times -1 minus -2 squared plus 1. Let's solve for a. Let's see, 0 equals a times -1 plus 2 would be a +1 squared plus 1. 0 equals 1 squared is just 1, so we'll just say a plus 1 minus 1 minus 1. A equals -1. So here the fact that it has a maximum of 1 is confirmed by this a value, because if the a value is negative, we know that a vertical flip has happened to this parabola. So its vertex at -2, 1 should be a maximum since the parabola is opening down. Let's write out our final equation for this one. Y equals a value of -1, just put a negative there. The x and the y have to go back, so it's just x minus a -2, we'll say plus 2 squared plus 1. All right. Write the following in vertex form. Let's go ahead and do this with number 7. So rewrite in vertex form. State the vertex, axis of symmetry, whether the vertex is the maximum or minimum, and the range for each parabola. We'll go over each of those. So for number 7, I'm going to store that 3 on the other side. I've got y over 3 equals x squared minus 4x plus, I'll just write it as 16/3. Now let's recreate the structure of vertex form. We'll keep our 16/3. This value here is always half of that value there, so that's going to be a -2. And the x minus 2 squared is going to become, in my head here, x squared minus 4x plus 4. So we're going to get back our x squared and our minus 4x, but we're going to get an extra 4, so let me subtract that away. Let me write it in terms of thirds. So 4 is the same as 12/3. So I'm going to subtract away 12/3 here. So I'm getting rid of my extra. Let's rewrite it by combine or like terms. Y over 3 equals the quantity x minus 2 squared plus 4/3. We will send the 3 back now. And we'll get y equals 3 times x minus 2 squared plus the 3, and the divide by 3 cancel out. So it's plus 4. All right, let's do everything it told us to do. The vertex is at positive 2 comma 4. Our a value is positive, so we know that this opens up. So we know that the vertex, if this is opening up, would be a minimum. You graph it in your graphing calculator if you want to double check that. The axis of symmetry is a vertical line, so it's going to be x equals, and it should go right through the vertex. The x value at the vertex is 2, so it's just x equals 2. Will give us the axis of symmetry and the range. Well, we know that this opens up, so it's going to be y is greater than or equal to the y value of the vertex, which is a 4. And for good measure, we'll just kind of sketch this using all that information. So 2 comma 4, opening up. So there's our axis of symmetry at x equals 2. And the y values, you can see this, the lowest the y values go is 4. And then it's y is greater than or equal to 4. It's every point's y value is bigger than or equal to 4. All right. I'll do 8 and 9 in slightly different ways. For number 8, as I attempt to find this equation in standard form, I'm going to show how to do this with matrices. It tells us to use matrices. I'll show number 9 with regression just to show it. But you're supposed to do both of these with matrices. Here's how I would do this. First, label each point x and y. Every point is an x and a y value. Then fill those x and y values into standard form. Y equals ax squared plus bx plus c, another form you have to have memorized. So let's see, the first one would be 3 equals a times 0 squared plus b times 0 plus c. That's after I plug that first point in. The second point would give us 4 equals a times 3 squared plus b times 3 plus c. And that third point would give us 6 equals a times 5 squared plus b times 5 plus c. Let's simplify those coefficients and rewrite it with our constants on the right-hand side. So this would become c equals 3, 9a squared plus 3b plus c equals 4, and 25a squared plus 5b plus c equals 6. Let me line that up a little bit better. Now let's turn that into a matrix. That's going to be the matrix. We'll have a column for A, B, C, and answers. So 0, 0, 1, 3, 9, 3, 1, 4, 25, 5, 1, 6. We're going to have to do reduced row echelon form on this. So I'm going to open up my graphing calculator. I'm going to go into the matrix by pressing second matrix, going over to edit, filling in those values, 0, 0, 1, 3. Next one was 9, 3, 1, 4. 25, 5, 1, 6. Leaving the matrix, going back into the matrix, going over to math, choosing reduced row echelon form, which is option alpha B. Going back into the matrix the third time, selecting the matrix we just edited, closing my parentheses, and getting my identity matrix, and the values for A, B, and C. I don't like these long decimals, so I'm going to go math, enter, enter, to turn them into fractions. So 2/5, -1/5, and 3 for my equation. So A equals 2/5, or 2/15, B equals -1/15, C equals 3. Turn that into an equation. Y equals 2/15 x squared minus 1/15 x plus 3 is the equation that would go through those 3 points. All right, let me just show how I would do this with regression for number 9. You're going to see it's actually a lot easier. 2/15 -1/15, 3. Okay, yep. So what I'm going to do is I'm going to go into my stat lists. So stat, enter, clear out any data that we see in there. And then I'm just going to enter my x datas for list 1, -2, 3, 0, y data, and to list 2, -16, 11, 2. Then I'm going to go stat, over to calculate, number 5 for quadratic regression, hit enter a bunch of times, and it's as easy as that. So yeah, you can see that was, it's almost cheating, it's so quick. -1.2, 6.6, and 2. So this one is y equals -1.2 x squared plus 6.6 x plus, I forgot, plus 2. So that's why I make you have to write the matrix that you used to prove that you can do it that method. All right. Let's just finish this up. Write the equation in standard form or vertex form to describe the following graphs. Vertex form much easier, but let's do both. This one has a vertex of 1, 3. That gives me my h and my k values. If I go 1 unit over, I hit my graph. If I go 1 unit down, so that gives me a equals -1. Put that into vertex form, y equals -x minus 1 squared plus 3. Let's convert that to standard form real quick by boiling out the x minus 1 times the x minus 1, getting an x squared minus an x, so that's minus a 2x plus 1 plus 3, y equals -x squared plus 2x minus 1 plus 3. Standard form is y equals -x squared plus 2x plus 2. All right, and that'll be that for this video. Have a good rest of your day.